Now we will see components of a vectors. Okay, let us consider the axis. This is y-axis and x-axis, and this will be a z-axis. Okay, and this is a origin. And let us consider a point A on x-axis. Okay, this is a point A on x-axis with the coordinates 1, 0, 0. So this is the point on the x-axis. Here this is the point, and with the coordinates 1, 0, 0. And we will consider another point B on y-axis. B means the x-axis will be 0, y-axis is 1 and z-axis is 0. We will consider another point C on z-axis. So this is a point on the z-axis. So the x-axis will be 0, y-axis 0 and z-axis will be 1. Now you can see here OA, the magnitude of OA or the length of OA will be equal to 1 unit. OB is also equal to 1 unit and OC is also 1 unit. I can write OA vector, OB vector and OC vector, right? Magnitude of OA vector is equal to 1, magnitude of OB vector is equal to 1 and magnitude of OC vector is equal to 1. So these are the unit vectors. We say these are the unit vectors along, this is the x-axis and this is y-axis, and along z-axis. These unit vectors are represented by I cap, j cap and k cap. This is important. Okay. These unit vectors are represented by x-axis is represented by I cap and y-axis j cap and z-axis will be k cap. Just the thing is you have to remember x-axis is represented by A and y-axis j and z-axis will be k cap along the xyz axis. Okay. Now let us see this one. See here I have considered the 3 dimension x, y, z axis is there. Let us consider a one point P. Okay. This is a point P with the coordinates x, y and z. Okay, this is in space now. We have to consider one point with the coordinates x, y, z. I mean the x-axis length will be x, y-axis y and z-axis will be z. Now here you can see this one OP vector. Okay, the vector OP vector is a position vector. OP vector is a position vector. Now we need to find this OP vector. Usually we represent OP vector by, in the previous session we have discussed this by R vector. Now we need to find this vector. Okay, we have to find OP vector. And what will be the magnitude of OP vector? Obviously the magnitude of OP vector will be, this is origin, 0, 0 will be there, point right, coordinates 0, 0. So this is x, y, z. Magnitude will be equal to square root of x square plus y square plus z square. I mean length of this OP will be root of x square plus y square plus z square. Now we have to find OP vector. Let us consider one point P1. Okay, this is the foot of the perpendicular from the point P. This is the point P1 will be a foot of the perpendicular from the point P. Now you can see here the vector OR. See, this is a vector. OR vector is parallel to P1 P vector. Right? OR vector is parallel to P1 P vector, and you know that this x-axis can be written as this x I cap because the length is considered as x. So this is a unit vector along the x-axis. So this will be x I cap and this will be y. Length is y. So this will be y j cap and this will be z k cap. Now you can see this P1 P vector, right, which is P1 P vector parallel to OR vector. Those are collinear. I mean same vectors OR vector. Since OR vector, this is represented by z k cap. P1 P vector is also represented by z k cap. Both are same vectors. Okay. See, this is P1 P and this OR vector is same. So OR vector is represented by z k cap. So P1 P vector is also z k cap. Now you can see this one Q P1. Is it clear? Q P1 vector. I'll write here Q P1. These are equal. Okay. Q P1 vector is equal to Q P1 is equal to OS vector. These are parallel. So you can see here QP1 is equal to OS vector. OS vector. So what is QP1? QP1 is equal to OS vector. OS vector is nothing but YJ cap. So here QP1 is also equal to YJ cap. Now next one is remaining here OQ in this direction. This is important here. OQ. O to Q, and here O is the initial point, and yes, O to S, and here O to R. So this will be now Q to P1, here O to S. So both are same values. Now here you can see this OQ, right, which is parallel to SP1. Is it clear? OQ is parallel to SP1. So OQ vector is equal to SP1 vector will be equal to XI cap. Is it clear? Now we have to find OP vector, right? We need to find OP vector. OP vector is nothing but if I join this O and P1. See here, let us join this O and P1 to find OP vector by using a vector addition. We can write OP vector as O P1 vector plus P1 P vector. Right? OP vector can be written as OP1 vector, OP1 vector from O to P1 plus P1 to P plus P1 P vector. Is it clear? So OP vector can be written as OP1 vector plus P1 P vector. Now OP vector, we don't have the value of OP vector, right? Vector. So we need to find OP vector. What is P1 P vector? P1 P vector is equal to Z K cap, right? So we'll substitute here. This is equal to O P1 vector plus Z K cap. Now we need to find OP1 vector. Now what is OP1 vector? Where is OP1? See here, OP1. We need to find O to P1, right? So listen carefully. O to P1 can be written as, here you can see this. This is a one triangle, right? So here by using the triangular law of addition, we can write this as OQ vector plus QP1 vector, right? OQ vector plus QP1 vector will be equal to OP1 vector. So we can write this as OQ vector. See, this vector notation is very important. OQ vector plus QP1 vector. QP1 vector. What is OQ vector? OQ vector will be equal to XI cap. So we will substitute this XI cap plus QP1 vector. QP1, that is QP1, so this is parallel to this one, or here you can see QP1 vector is equal to YJ cap. So this will be equal to YJ cap. Just will substitute here. So by this we can write OP vector is equal to, that is XI cap plus YJ cap plus Z K cap. Simple it is. Just you have to remember this one. OP vector. Suppose this is a point with coordinates x, y, z. Then OP vector, or we can represent that as R vector is equal to XI cap plus YJ cap plus Z K cap, and magnitude of OP vector is equal to root of square of that x square plus y square plus z square. Okay, just you have to remember OP vector is equal, if it is coordinates are x, y, z, then xi cap plus yj cap plus zk cap will gives you a vector, OP vector. Then magnitude is root of x square plus y square plus z square. Okay, I hope you understood this one. Now we will see how to add two vectors. Okay, simple it is. Just you need to add the corresponding elements, that's it. See, if I consider A is a vector with elements A1 I cap plus A2 j cap plus A3 k cap. Is it clear? So this is a point with the coordinates A1, A2, A3. So, and one more will be B vector is equal to B1 I cap plus B2 j cap plus B3 k cap. Is it clear? This is along the x-axis. This represents along x-axis, this is along y-axis, and this is along z-axis. Now addition of two vectors, a vector plus b vector, simple it is. Just you need to add the corresponding elements, I mean x-axis elements, y-axis, then z-axis. So this is now a1 plus b1 I cap, okay, plus a2 plus b2 j cap plus a3 plus b3 k cap. This is about addition. Subtraction is also similar. a1 minus b1 I cap plus a2 minus b2 j cap and plus a3 minus b3 k cap. That is a vector minus b vector. If you want to find b vector minus a vector, then it will be b1 minus a1 I cap, b2 minus a2 j cap and b3 minus a3 k cap. If you want to multiply by any scalar, see, let us consider lambda is a scalar. So this is lambda into a vector is equal to, you have to multiply each and every element of this vector by lambda. So that will be lambda a1 I cap plus lambda a2 j cap plus lambda a3 k cap. This is the scalar multiplication, and any two vectors are equal. To say any two vectors are equal, their corresponding elements should be equal. That means to say a vector is equal to b vector. Okay, a vector is equal to b vector possible only when a1 should be equal to b1, a1 should be equal to b1, and a2 should be equal to b2. Then a3 should be equal to b3. Then only we can say that two vectors are equal. Remember one thing, if it is to say any two vectors are collinear, they should be parallel, right? Let us consider one vector, a vector. If I multiply by a scalar lambda, that will be lambda a vector. Obviously these two vectors will be collinear, right? They will be parallel. Lambda may be positive or negative. If it is negative, then direction will be opposite, right? Other than that, those two will be parallel. So two vectors, suppose a vector and b vector are the two vectors. To say these two are collinear, if and only if, okay, important one, to say these two vectors are collinear, if and only if a vector is equal to lambda into b vector. Is it clear? A vector is equal to lambda into b vector. I mean a vector and lambda a vector. If you multiply by any scalar, then they will be parallel. So we can write a vector is equal to lambda into b vector. If it is, for example, a vector is given in the component form, let us consider a1 I cap plus a2 j cap plus a3 k cap. Now b vector is given as b1 I cap plus b2 j cap plus b3 k cap. Now let us substitute here. A vector is a1 I cap plus a2 j cap plus a3 k cap is equal to lambda is multiplied with b vector. So we need to multiply each and every element. So this will be lambda b1 I cap plus lambda b2 j cap plus lambda b3 k cap. Right? See here, two vectors are equal. That is nothing but their corresponding element should be equal. Right? So here I cap. So that means a1 should be equal to lambda b1. Right? Then a2 should be equal to lambda b2 and a3 should be equal to lambda b3. So here we can write, see this one, a1 by b1 is equal to lambda. Right? Here a2 by b2 is equal to lambda, and here a3 by b3 is equal to lambda. That means their ratio should be equal to the constant. So by this we can write a1 by b1 is equal to ratios a2 by b2. This is equal to a3 by b3. That should be equal to one constant. Very important one. Okay. Ratio of those two values should be equal to a constant. Then they will be a collinear. Okay. Then one more thing here. a1, a2, a3. In this vector, a1, a2, a3 are called direction ratios. Okay. Direction ratios. If it is in the place of direction ratios, if it is direction are given. Direction cosine is nothing but L, M, N. Okay, L is nothing but cos alpha, M is cos beta, N is cos gamma, and alpha, beta, gamma is the angles. With respect to the axis x, y, and z. Right? Then if it is this L, M, N is given, then that can be written as L I cap plus M J cap plus N K cap. Is it clear? If it is direction ratios are given, A1 I cap, A2 I cap, A3 K cap. Direction ratios. If it is direction cosines are given, then that can be written as L I cap plus M J cap plus N K cap. I hope you understood this one. Now vector joining two points. Okay, we need to find vector joining two points. That vector we have to find and magnitude of that vector. First, let us consider our axis. Okay. And this is the origin, and this is x-axis, and this is y-axis, and this will be a z-axis. Now we will consider unit vector. So this will be 1 unit, and here 1 unit, and this is 1 unit. Yes, 1 unit along the x-axis is represented by I cap, and y-axis is represented by j cap, and z-axis is represented by k cap. Important one, you have to write these things. Now vector joining two points. That means we need to find. We need to take 2 points, right? Let us consider this is a 1 point and this is a second. We will consider this as P1 with this point as P2. Now we have to find vector joining 2 points. We need to find the P1 P2 vector or P2 P1 vector. With the coordinates, we will consider this as because x1, y1 and z1, and here we will consider this as x2, y2 and z. Along x-axis x2, y-axis y2 and z-axis z. Now we have to find this vector P1 P vector or P1 P2 vector, or we can find P2 P1 vector. See, if you find P1 P2 vector, then the magnitude will be same, but only it differs in their direction, right? P1 P2 or P2 P1 vector. Now let us join OP vector, OP1 vector. Okay, so this is in this direction OP1 vector, and we'll join OP2 vector, OP2 vector. Now we have to find, see this one, OP1 vector, and here OP2 vector is there. If I write OP1 vector plus P1 P2 vector, is it clear? By using the triangular law of addition, OP1 vector plus P1 P2 vector. See here, OP1 vector plus P1 P2 vector is equal, OP1 plus P1 P2 will be equal to OP2 vector. This is a one case, or else you can go like this, OP2 vector plus P2 P1 vector is equal to OP1 vector. Okay, that is also possible. Here we will go with OP1 plus P1 P2 vector is equal to OP vector. We need to find P1 P2 vector, right? So here we can write P1 P2 vector is equal to OP2 vector minus OP1 vector. Now what is OP2 vector? OP2 vector is a position vector, right? Here with the coordinates x2, y2, z. So this one can be written in the component form, right? So OP2 vector can be written as x2 I cap plus y2 j cap plus z2 k cap minus OP1 is also a one position vector with coordinates x1, y1 and z1. So this one can be written as x1 I cap plus y2 j cap plus z2 k cap. Now two vector, you have to subtract two vectors. What you have to do? You have to subtract the corresponding elements, right? So this is equal to now x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is the vector joining the P1 P2 vector. Is it clear? If it is any two vectors are given, P1 and P2, then what we can write this as x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. That is P1 P2 vector. Remember, P1 P2 vector will be equal to, start is x2 minus x1, y2 minus y1, z2 minus z. If I want to find p2, p1, then it will be x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. So this is about the vector joining two points. Then obviously the magnitude of that, magnitude of p1 p2 vector is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now here you can see this one. I mean magnitude of the p1 p2 vector and p2 p1 vector both will be same, but vectors are different. Is it clear? p1, see the difference between this p1 p2 vector. If you want to find, go like this so that you can find p2 p1 vector. So here you will get x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. Limit is, while solving the problem you will understand this one, but still see here we found p1 p2 vector. If it is p2 p1 vector, see here I have considered o p2 plus p2 p1 will be equal to o p1 vector. So we can write, see o, see the direction, here this is p2 p1, here we consider the direction as p1 to p2. See this is o p2 vector plus p2 p1 vector will be equal to o p1 vector. Now I need to find p2 p1 vector. p2 p1 vector is equal to o p1 vector minus o p2 vector. So clear? o p1 minus o p2. Here we p2. Here we got o p2 minus o p1. So this will be now x1 minus x2, right? So this is equal to now x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. Is it clear? The difference between these two, p1 here, sorry, p1 p2 vector and p2 p1 vector, but the magnitude will be same. Remember this. Now see these problems. This type of problems are important for 1 or 2 marks. Okay, simple it is. Find unit vector in the direction of a vector. A vector is equal to 2 I cap plus 3 j cap plus k cap is given. See here, this is a one vector is given and this is not the unit vector. Unit vector is nothing but which one, the magnitude should be equal to 1. So this is not the unit vector. You have to find the unit vector along this direction of this vector. Is it clear? How to find the unit vector? There is a one formula, right? In the previous session we have discussed a unit vector is equal to 1 by magnitude of a vector, right? 1 by magnitude of a vector into a vector. Simple it is. A unit vector is equal to 1 by magnitude of a vector into a vector. First we will find the magnitude of a vector. Magnitude of a vector is equal to root of 2 square 3 square, right? 2 square plus 3 square plus 1. 2 square will be 4 plus 3 square will be 9 plus 1. So this is equal to root 14. Is it clear? That is root 14. Now a unit vector, better you write the unit vector in the direction, better you write in the direction of vector A. Vector A is given by this. Now a cap is equal to 1 by root 14 into a vector. So as I told you, this is one scalar which is multiplied with the vector. So just you have to multiply each and every element of that. So it will be 1 by root 14 into a vector is 2 I cap plus 3 j cap plus k cap. So this is equal to now 2 by root 14 I cap, but like this, okay, 3 by root 14 j cap plus 1 by root 14 k cap. So this is a unit vector of a given vector. Now if you find the magnitude of this vector, it will be equal to 1. Read the question carefully. Find a vector in the direction of the vector. Vector is given. A vector is equal to I cap minus 2 j cap that has magnitude 7. Okay, you have to find the vector in the direction of this vector that should have a magnitude as 7. For that what we can do? First we will find a unit vector. Okay, unit vector is nothing but it has a magnitude 1. If you multiply by that vector with 7, obviously the new vector is having a magnitude as 7. Is it clear? You have to find the magnitude, you have to find the vector that should have a magnitude as 7. So first we will find the unit vector, then we will multiply that unit vector with 7. Obviously the magnitude will be equal to 7. Now first we will find the unit vector. A cap is equal, directly I will write 1 by determinant of A vector or magnitude of A vector into A vector. So this is equal to 1 by magnitude of A vector will be root of 1 plus 2 square is 4. It will be root 5, right? Into A vector is I cap minus 2 J cap. So I can write this as I cap divided by root 5 minus 2 by root 5 into J cap. Now this is a unit vector, nothing but it has a magnitude 1. Now we have to find the vector which has a magnitude 7. So we will multiply 7 with the unit vector. So this is equal to, now multiplying by a scalar. So this will be 7 by root 5 I cap minus 2 into 7 will be 14 divided by root 5 J cap. So this is the answer. Simple one, important for 2 marks. Find unit vector. You have to find the unit vector in the direction of the sum of the vectors. Okay, you need to find the unit vector for the sum of these two vectors. First, what you have to find? Obviously, sum of these two vectors. Let us consider C vector is equal to A vector plus B vector. What you have to do? Add the corresponding terms. So 2 plus 2 will be 4 I cap plus 2 plus 1 will be 3 J cap and minus 5 plus 3 will be minus 2 K cap. Right? Just subtracting the or adding the corresponding terms. Now C vector, unit vector is equal to 1 by magnitude of C vector into C vector. So this is equal to 1 by root of magnitude of C vector. 4 square will be 16 plus 9, 25. 25 plus 4 will be equal to 29, right? So this is root 29 into 4 I cap plus 3 J cap minus 2 K cap. So this can be written as 4 divided by, this is important, okay? You have to expand it, you have to write like this, 4 by root 29 I cap plus 3 by root 29 J cap minus 2 by root 29 K cap. So this is the answer. And this vector algebra chapter is the easiest chapter, everyone can solve. Simple problems are there. Okay, see this one. Write the direction ratios of a vector. What is mean by direction ratios? The values of A, B, C. Right? What are the direction ratios? I can say 1. Right? Coefficient of I cap, that is 1, and J cap will be 1, and coefficient of this will be minus 2. So these are the direction ratios. Is it clear? Direction ratios of a given vector are along x-axis 1, y-axis 1 and z-axis minus 2. That is 1, 1 and minus 2. So these are the direction ratios. We can represent A1, A2 and A3. Now what is given? Hence calculate its direction cosines. What is meant by direction cosines? The values of L, M and N. Right? We have stated L is equal to x divided by magnitude of r vector, right? X divided by magnitude of r vector. In the place of x, here we have 1. You can consider a1 or x, anything. So this will be 1. Is it clear? L. M will be y by magnitude of r vector. N will be z by magnitude of r vector. So what we can write? L is equal to, the value of x is now here 1, right? Divided by magnitude of r vector. This is if I consider, this is magnitude of a vector here, okay, in the place of here. So what we can write? L is equal to, see, that can be written as a vector is equal to a1 I cap plus a2 j cap plus a3 k cap, right? Now L can be written as a1 divided by magnitude of a vector. M will be a2 divided by magnitude of a vector, and n will be a3, a by a3 divided by magnitude of a vector. Is it clear? L is equal, a1 is 1 divided by magnitude of a vector. What it is? 1 plus 1 will be 2, 2 plus 2 square will be 4. 4 plus 2 will be equal to 6. So n is equal to 6. And m is equal to a2 by log root of a2. That is 1 by root 6. Right? And n is equal to a3 divided by a3 is now minus 2. So minus 2 divided by root 6. Is it clear? So finally we have tried. Therefore direction cosines are ordered triplets element, that is 1 by root 6 comma 1 by root 6 and this is minus 2 by root 6. So this should be the final answer. Find the vector joining the points. Okay, vector joining the points. 2 points are given, P and Q, directed from P to Q. P to Q is nothing but, here P is the initial point and Q is the terminal point. So directed line, this is a so you have to find the what vector joining two points, that is PQ vector we need to find, right? PQ vector is equal to P to Q. Remember, P to Q will be minus 1, minus 2 and minus 2, minus 3, then minus 4, 0. Is it clear? If it is P to Q. Now, in the last we have discussed, right, how to find the vector joining points. So, PQ vector will be, I'll write directly, minus 1, minus 2. You have to start with Q. Remember, PQ is nothing but you have to start with Q. If it is QP, then you have to start with P. Remember in that, okay? Here PQ is this, so we'll start with Q. That is minus 1, minus 2, minus 1, minus 2, I cap, x coordinate, plus minus 2, see here, minus 2 and y coordinate is 3, minus 3, j cap, plus here this is minus 4, is it clear? Minus 4 and this will be minus 0, j cap. If you want to find QP, then start with P. Now this is equal to minus 1, minus 2 will be minus 3, I cap. This is minus 5, j cap and that will be minus 4, k cap. So this is the PQ vector. Is it clear? PQ vector is equal to minus 3 I cap, minus 5 j cap, minus 4 k cap. If you want to find the magnitude of this one, you can find square root of 3 and plus square of 5 plus square of 4. That will give you a magnitude of this PQ vector. Okay. In the next session, we will move to the section form.